Hey, what's up guys? It's Nicola from Calcunic, and today we're going to talk about absolute value equations and inequalities. Let's get right into it.
So we're going to start this video off today by talking about what an absolute value actually is, its definition. If you don't need the refresher, feel free to skip ahead to whatever part of the video you would like to watch. I have all the time cards in the description, so skip right ahead to whatever you need. Otherwise, let's get started. So an absolute value, it may be a little intimidating, but it's actually quite simple. You could think of it as the magnitude or the distance from zero of any given number. So let's say we're trying to find the absolute value of 2. So in our number line, 2 is right here, and its distance from 0 can be given by the straight yellow line. And so the distance is just 2, right? So the absolute value of 2 is equal to 2. Let's say we're asked to find the absolute value of -1. Well, -1 is right here, and the distance from 0 is given by this straight line here. And since distance can't be negative, we know it's not -1. So the distance is just 1 right here. And so we have that the absolute value of -1 is equal to 1. Now we see a pattern here, and we could formalize this. We could say that the absolute value of x is equal to x if x is greater than equal to 0, right? Because if it's positive, we don't have to do anything. Or if it's negative, so we'll say it's minus x if x is less than 0, or if x is negative. Now, let's try to use this and solve some slightly harder problems. Now, let's say we're asked to find x if the absolute value of x minus 2 is equal to 4. And so as before, we'll use the definition of the absolute value, and we say that absolute value of x minus 2 is equal to x minus 2 if x minus 2 is greater than or equal to 0, and this is the same as saying x is greater than or equal to 2 just by rearranging the equation, or it's equal to minus x minus 2 if x minus 2 is less than 0, and this is the same as saying x is less than 2 by rearranging again. And so we have two cases with two separate restrictions, and so now we'll work with those two cases. So case 1, we have that x minus 2 is equal to the absolute value of x minus 2, and that's equal to 4 per the question, and by rearranging we get that x equals 6. Checking back, we see that x needs to be greater than or equal to 2, and 6 is indeed greater than or equal to 2, so this is good. This case works. Our second case, we have that the absolute value of x minus 2 is equal to minus x minus 2, and this is equal to minus x plus 2, and it's equal to 4 as per the question, and by rearranging we get that x is equal to -2. Once again we need x less than 2, and well, -2 is indeed less than 2, so this case works as well. And therefore we can conclude that if the absolute value of x minus 2 is equal to 4, we have that x is equal to -2 or 6. All right, let's move on to a slightly harder question. We're asked to find x if the absolute value of x plus 1 is equal to the absolute value of x. And now in this case, we have x in two separate absolute values, so we're going to need to do two separate sets of two cases. So first we start off by saying the absolute value of x plus 1 is equal to x plus 1, and that's going to be when x plus 1 is greater than or equal to 0, or when x is greater than or equal to -1, and it's equal to minus x minus 1 when x plus 1 is less than 0, or when x is less than -1. And on the right hand side, we have that the absolute value of x is equal to x when x is greater than or equal to 0, that's pretty straightforward, or -x when x is less than 0. And so now you may be thinking that we need to do 4 separate cases to solve this problem, but actually we could simplify it a little bit by realizing that some of these cases have some overlap. Let me show you what I mean by that. So here below, I have a number line with x plus 1 and x on it, and so notice that when we input a number greater than or equal to -1 into x plus 1, we get a positive value. And we input a number greater than or equal to 0 into x, we get a positive value. That's pretty clear. And if we input a number less than negative 1 into x plus 1, we get a negative number. And if we input a number less than 0 into x, we get a negative number. And so hopefully you can see here what I mean. We have some overlap. So if x is less than negative 1 in this sector here, both x plus 1 and x are negative. If it's in this small sector here in between negative 1 and 0, then we have x plus 1 is positive, but x is negative. And finally, if it's in the last sector here, in that case, both x plus 1 and x are going to be positive. Let me write down these three respective sets so we don't forget them. So first, we have that x is an element of minus infinity to minus 1 exclusive. 2 is x is an element of, negative 1 inclusive to 0. And 3 is x is an element of 0 inclusive to positive infinity. And x element just means that x is a part of that set. It's somewhere in between the restrictions. Now you may be asking yourself, why did I use inclusive brackets and exclusive brackets for sum? And basically the reasoning for this has to do with the actual definition. Here we have that x plus 1 is going to be negative when x is strictly less than negative 1. So therefore I'm not including negative 1 in this set. In set 2, we have that x plus 1 is positive when x is greater than or equal to negative 1. So negative 1 is included, but 0 is not, because 0 is only negative when x is strictly less than 0. And for the last case, we have inclusive because they're both positive when x is greater than or equal to 0. So what we're going to have here is going to be both x plus 1 and x are negative, so their absolute values will output minus x minus 1 is equal to minus x. Rearranging, we get minus 1 is equal to 0. And hopefully everyone can see that this is impossible. Going on to the second case, so we have x plus 1 is equal to minus x because x is just negative here. Rearranging, we get 2x is equal to negative 1. And so therefore x is equal to negative 1/2. Looking back, we have that x has to be an element of negative 1 to 0. Negative 1/2 is in that range, so therefore this is a valid choice for x. And finally, we're going to have both x plus 1 and x positive, so x plus 1 equals x, rearranging 1 equals 0, and once again this is impossible. And so therefore the only solution to this problem is just x equals negative 1/2. So now we're moving on to inequalities. We're asked to find the range of x given that the absolute value of x minus 1 is greater than 2. And so don't get intimidated by the inequality as opposed to the equality. The approach to solving this is almost nearly identical as to before. Once again, we start by saying that the absolute value of x minus 1 is equal to x minus 1, and that's when x minus 1 is positive or greater than or equal to 0. And this is just the same as saying x is greater than or equal to 1. And then we have minus x plus 1, just negating that. And that's when x minus 1 is less than 0, or when x is less than 1. And so we have our two cases, and we're just going to go ahead and solve for it. And so in our first case, we have that x is greater than 1. So the absolute value of x minus 1 is going to output x minus 1, and this must be greater than 2 as per the question. And by rearranging, we get x is greater than 3. And by checking here, x needs to be greater than or equal to 1. And we have x is greater than 3, so this is valid. We give it a quick check mark. And in our second case, we're testing for x values less than 1. And so therefore the absolute value of x minus 1 outputs minus x plus 1. And that has to be greater than 2 for this question. And by rearranging, we get that x is less than negative 1. And once again, by checking, we need that x is less than 1. And well, negative 1 is less than 1, and all these values of x will be 2. So this works as well. So we have that x is greater than 3, or x is less than negative 1. And by writing in set notation, we could say the same thing by x is an element of negative infinity to negative 1 exclusive because of the strict inequality. And this is with the union of 3 exclusive because, again, of the strict inequality, all the way to plus infinity. And that's it. Okay, time for our last and, in my opinion, the hardest problem. We have to find all x such that the absolute value of x plus 1 over the absolute value of x minus 1 is greater than 3. And so before we start doing any calculations, I just want to note that we have x minus 1 in the denominator, and we know that we can't have 0 in the denominator, so we need to outright state that x cannot be equal to 1. Write it in bright colors so you don't forget it. X can't be 1 because then 1 minus 1 is 0, and then we're dividing by 0, which is undefined in math. So just right off the bat, x is not equal to 1. However, the rest of the problem is pretty straightforward as we have been doing it before. We're going to write out the intervals that make x plus 1 and x minus 1 positive or negative. So if you want to skip ahead a bit, because this is quite repetitive, feel free to do so and get to the actual good stuff. But if you want to stick around, we have x plus 1 if x plus 1 is greater than or equal to 0, and that's when x is greater than or equal to negative 1. And then we have minus x minus 1, just by negating x plus 1, is when x plus 1 is less than 0, and this is when x is less than negative 1. Moving on, we go to x minus 1. It's pretty similar. This is equal to x minus 1 when x minus 1 is greater than or equal to 0, or when x is greater than or equal to 1. However, we know x cannot be 1, so we'll erase that. We'll just write x is greater than 1. And then we have the negation minus x plus 1 when x minus 1 is less than 0. And this is the same as saying x is less than 1. And so now let's take out our number line and find out which intervals we should focus on. So I've conveniently already drawn this out. And if we look at the interval here, we have that when x is greater than negative 1, we have that x plus 1 is positive. When it's less, it's negative. And we have x is greater than 1, we have x minus 1 is positive. And when it's less, it's negative. So visually, we could identify 3 separate intervals. Our first one, both x plus 1 and x minus 1 are going to be negative. The middle one will have x plus 1 is positive and x minus 1 is negative. And the third final interval, we have both x plus 1 and x minus 1 to be positive. And so now let's actually go and write these down. Our first interval is x is going to be an element of minus infinity and less than negative 1 exclusive. Our second interval is x is an element of, minus 1 inclusive this time, all the way to 1 exclusive. And our final interval, we have x is an element of 1 exclusive. Remember, x cannot be equal to 1, and all the way to positive infinity. So let's go ahead and try to solve this now. And so for the first interval, we'll have both x plus 1 and x minus 1 are negative, so their absolute values will output their negations. We have minus x minus 1 all over minus x plus 1, and this has to be greater than 3. By rearranging, we get minus x minus 1 is greater than minus 3x plus 3. Rearranging again, we get 2x is greater than 4. Once more, we get x is greater than 2. However, if we take a look, we have that x needs to be in between negative infinity and negative 1. And unfortunately, no value of x in that interval satisfies this expression. So therefore, this interval is invalid. Going on to the second one, we have x plus 1 is going to be positive. So we have just x plus 1 from the absolute value all over negative x plus 1, because x minus 1 is going to be negative here, and this is greater than 3. Rearranging, we will get x plus 1 is greater than minus 3x plus 1. Rearranging again, we have 4x is greater than 2, or x is greater than 1/2. And so we see here that we have x is an element of minus 1 to 1, and x is greater than 1/2. So we get an element for x. We get an interval for x, on this specific interval, we say that x is an element of 1/2 exclusive to 1 exclusive. Our third and final interval, we have both x plus 1 and x minus 1 will be negative here. So their absolute values simply output themselves. It must be greater than 3. And so by rearranging, we have x plus 1 is greater than 3x minus 3. Rearranging again, we get, what do we get? We get 2x is less than 4, or x is less than 2. And if we look at the initial interval, x must be greater than 1. So therefore, x is an element of 1 to 2, both exclusive. And so putting this all together, we could write our conclusive statement. X is an element of 1/2 to 1 with the union of 1 to 2. And that's it.
Alright guys, thank you so much for watching. If you had any questions about the video or just other video suggestions, drop them down in the comments below. I do try to get to all of them. And if you liked the video, if you learned something, consider liking and subscribing. It would really help me grow my channel, reach a greater audience, and hopefully help more people with math. That's all from me. Till next time.